Now we will start with triangle law of vector addition. Here there is one vector A which is along the x-axis. Let us draw it like this. Vector A along the x-axis. One vector is vector B. Okay, this vector is making some angle theta or say some angle alpha, because I have taken here alpha with O and R and theta with, okay, so we can take it as theta. Here we have taken theta, so let us continue with theta. Let us follow this diagram. So there is this vector A and this is vector B making some angle. Now I am going to join them. Okay, so I join them like this. A, B. B is still making some angle, theta. Okay, so this is A, this is B. So what do I get? I get two sides of a triangle. There are two vectors. Again listen to me, A and vector B. It is B is making some angle, theta. Now I join them. How do I join them? Terminal point of A, I start with another vector B. Okay. How should I write the resultant? Starting point of first vector to the terminal point of the last vector. So this is my resultant R. Okay. This must be making some angle alpha. Okay. Because we have taken alpha here. So this is how the diagram is made. So let us look at the diagram. This is vector A, OP, side OP of a triangle. This is vector B, which was making some angle theta. So let this side be PQ. This side is PQ of the triangle, and we have joined them as we have joined here. We have joined them here. That is resultant vector R. Now this is making an angle alpha. The resultant vector is making an angle alpha. A and B are at angle theta. Okay, so this is my diagram. Now I will draw some extension to the diagram. What extension will I draw? Is that I will drop a perpendicular from point Q here till A, that is E, level of A, and I will extend this A further to meet here at point E. Okay, so that is what I have done. I have done this extension for finding out something. Okay, now this is the arrangement. Now what is this? Vector A is OP, vector B is PQ, QE and PE is something I want to find out. Okay, now this whole triangle, that is triangle OQE, is a right angle triangle. Because I have dropped a perpendicular, this is 90 degrees. So this full triangle is a right angle triangle. That is triangle OQE is a right angle triangle. Okay, so please note this. After that, if I am using a right angle triangle, I can use Pythagoras theorem. So what is OQ square? OQ square is OE square plus QE square. That is, the resultant square is the addition of square of two opposite sides. This is Pythagoras theorem. So OE square, that is this side, plus this side square. So this is how I have returned this. Now let me substitute OE, because OE straight is not A vector, right? It's little extension of A vector. So this is OP, that is OP plus PE. Okay, this is broken into two parts. So this is OP plus PE the whole square. Okay, I am just writing the details of OE plus QE square plus QE square. Okay, QE doesn't have any detail. It is not split. Only OE is split. Okay, so I write this. Now I take triangle PQE or QPE anyway. Okay, so I have taken triangle PQE. This small triangle which is made here is also a right angle triangle. Here also I can use Pythagoras. So now what is cos theta? In this, what is cos theta? PE, that is adjacent side, divided by PQ. So PE divided by PQ. So what is PE? We don't know. We don't know what that length PE is known as. But do we know what is PQ? Yes, PQ is vector B. So let us substitute. So cos theta is PE divided by vector B. Vector B. Okay. Now what is PE? I just have to take the denominator B vector cos theta. So I find out what is PE. Now what is PE? This is like resolution of vectors. This is B cos theta. Now let me take sin theta. So what is sin theta in this triangle? Same triangle, QPE. Okay. What is sin theta? Opposite side QE divided by PQ or QP, anything. Now QE, we don't know what it is known as. We don't know. We are finding out. And what is QP? It is vector B. So again I cross multiply it. I get QE as B sin theta. So what did I achieve? I achieved, see, I want to write the Pythagoras theorem for this whole triangle. But because I don't know what are these extensions known as, I am trying to find out this extension with respect to the vectors. Okay, so I got PE to be B sin theta and I got QE to be PE to be B cos theta and QE to be B sin theta. So I got some representation for these two. Okay, so this is what I achieved. Okay, but then I have to put it in the main formula. So let us put it in the main formula. OQ square. Okay, it was OP plus PE square. Now what is OP? What is OP? A vector. And what is the small vector now? B cos theta. So let us put this, let us substitute this, the whole square. Same thing here, I am just putting this, substituting it. Plus, what is QE? B sin theta. But it was QE square. So B square sin square theta. Okay, so this is B square sin square theta. This is actually going to be one number. So you are just squaring that number because we don't know the value of sin theta and B. Right now we are writing as B square sin square theta. Okay, so this is what I get. Now this is like A plus B the whole square. Okay, so what it is in trigonometry? A square plus 2AB plus B square. Same way we are going to do this. A square plus 2AB cos theta plus B square. But B square is your B square cos square theta plus B square sin square theta. So I have just put this as A plus B the whole square. Now I take it down. A square plus 2AB cos theta. This here B square is common. So let me take these two together. Write B square outside the bracket. Sin square theta plus cos square theta. We have learnt in trigo it is 1. Sin square theta plus cos square theta. So this value becomes 1. So I need not write it. So this equation becomes, in between, what is OQ? OQ is resultant R. So I can substitute this by resultant R square. So I carry forward this A square plus 2AB cos theta plus B square. This is the equation I will get for the resultant vector. So this is the equation for magnitude of the vector. Okay, so if I want R, what will I do? I will take under root of this. Okay, I will take the whole under root of this number. So I can take it like that. R is equal to A square plus 2AB whole under root. Okay, so this will be my resultant R. But supposing I want to find out what angle the resultant R makes with the x-axis, that is alpha. How will I find out alpha? Again, this is a big triangle. So alpha will be, what will be tan alpha? Opposite side QE divided by OE. So QE upon OE. Okay, I will require the whole triangle. I can't have a small triangle that time. Okay, so what is QE? QE is B sin theta. What is OE? OE is split into two parts. A plus B cos theta. So whenever I will put these values, I will get alpha. the angle alpha. Now let us try this with one example. Okay, so I will write down the example over here. You will do the calculations. You will do the calculations and tell me the answer for it. Okay, at the end of this I will write down the answer. Please cross check if you are getting the same. Okay, A, let it be 5. Okay, let it be 5 units, and let B be 6 units. Okay, now with the help of this theta, let us take it simple to be 30 degree. Okay, with this information you have to find out R, and you have to, R is with this formula, R, value of R and value of alpha. Now what I will do is that I will write down, you just have to put in the formula and write it down. Okay, so I will write down, you have to cross check. You can stop the video, first do your own calculation, then cross check with mine. I have substituted the values. I will get 10.6 as the answer. Don't forget doing under root at the end of it. Okay, so you should do it. When you are doing it in the calculator, put this one into a bracket and then do the next addition. Okay, so you do 5 square plus bracket, write this bracket close, plus 6 square. When you get the answer, then go for under root. Otherwise you will get wrong answers on the calculator. Let us try with alpha. Now this is my tan alpha. See, whenever you get this tan alpha, here also when you are dividing, put this in the bracket. Okay, that is 5 plus 6 cos 30, put it in the bracket. You will get the answer 0.29. But I don't want tan alpha, I want alpha. So alpha will be tan inverse of 0.29. How do you do tan inverse on the calculator? Shift tan. Okay, so there is a shift and tan. So when you do shift tan of 0.29, then type the number 0.29, you will get the answer to be 16.4. do not forget to put your calculator in degree. In radians you will not get these answers.